Hey guys, welcome to the homework 2, or nope, wow, homework 2. This is September. The homework 5, lesson 2.2 backside video. So this is what we did in class today, graphing different types of functions, looking for its attributes. A lot of you mentioned that this was a review, which is awesome. So hopefully you won't even need this video as a tool, but just in case you do, I'm going to talk through it. Sometimes a little bit of review is good too. I had a couple of conversations like that today. Sometimes looking back at what you know can be really encouraging too, because you can just get straight hundreds, right? That's what I'm hearing if I'm hearing complaining about how we've done this before. So let's start with this upside down parabola and figure out its attributes. So we have this one. We see that this vertex at the top is already labeled for us. That's awesome at 2800. The paper cuts off a little bit when I go up, so I'm going to label it on the graph so you can see where I'm talking about, and then we will talk later about what the numbers for each of these are specifically. So let's start with the x-intercepts. We have an x-intercept here and here. Once again, an x-intercept is where our graph crosses the x-axis. Those are x-intercepts. Y-intercept, we see that our parabola crosses our y-intercept also at this point in the corner. We have our maximum. It never gets any higher than that point right there. Our minimum, I just drew over them, but it does not look like we have a minimum because we see arrows going, so we don't really know. That's going to keep going and going and going. So that's kind of what we know about our minimum. And then we'll talk about domain and range. So once again, domain is going to be our x values or our inputs, and range is going to be our y values or our outputs. So now let's put some specific numbers on this graph. So we have our x-intercepts. We saw that our x-intercepts were 0, 0, and also this one, so 40, 0, because our graph here crosses the x-axis in two different places. It only is going to cross our y-axis in one place, however, and we see that it's going to cross our y-axis at 0, 0. Or, yeah, we're just going to write it that way. Our y-intercept is over here at 0, 0. Our maximum is going to be the point 2800. Or we could also say, so where y equals 800, because our maximum normally here is going to be our highest y value. See that up here, 2800, our maximum value is the vertex of this parabola. In our minimum, so if we're looking at this graph specifically, right, we'd say it's 0. We do see that there are arrows here, though, so we know that the graph's going to continue going. So the minimum, I'm going to say it doesn't apply. We don't have a minimum on this graph. Or our minimum, we could also say negative infinity, but basically the minimum is not able to be defined on this graph. So now we're going to talk about domain. Okay. Quick second. So this up here, I didn't read our directions, which is always our first thing. A projectile was launched from a catapult. The path it took is graphed below. Find the key attributes. So if we're placing this graph in the world of the fact that we launched it from a catapult, we would have a minimum, right? I know it says that there's arrows, but if we're launching a projectile from a catapult, we're never going to have a projectile that goes lower than the ground, right? The ground is as low as it can go, and right here our ground is at 0. So we're actually going to say that our minimum is 0, because this, in the world of our word problem, is our ground, and it's never going to go below ground level. So really, if we are drawing this graph ourselves, we wouldn't want to put the arrows at the end, because that signifies it would keep going, when in actuality we're representing something that happens in the real world, and we need to consider that as well. So we're going to say our minimum is 0. So now looking at our domain, domain, remember, is our x values or our inputs. And I can input anything on my x-axis from 0 to 40, right? Those are my two x-intercepts, notice, 0 and 40. So this is my domain. Anything in this range is fair game for a point that I could consider as an input for my function. Let's now think about range. Here, again, if we're considering this to be the ground, which it is because this is a real world example, our range is going to be from here all the way up to the top, right? So my range is going to be from 0, or the ground, all the way up to 800, which is up here, because that is my maximum. So as you can see, we can use a lot of other attributes of the function that we found before to explain our domain and range. Our maximum in our minimum help to explain our range, and our domain in this case is going to be our x-intercepts, which is pretty cool. Once again, if you have any questions on that, or you want to challenge me on the idea that the minimum in this case is going to be 0, I will welcome that debate. So come and talk to me or Miss Avera. I am choosing to place this as a real world problem though, just so you know. All right, let's move on to this next one, which we actually don't have to do because I can't read the values, which means you can't read the values. So we're not going to talk about this one. I also don't think that this should be an absolute value function. So if you have any insight into that, I've not been able to figure it out. So come talk to me about that too. Moving on here, we have our 2 ACT problems. The first one's an econ problem, so I'm super excited. So Johnny is selling lemonade. He paid $5 for his supplies and charges 50 cents per glass of lemonade. Johnny's profit is found by subtracting his expenses from his income. Which of the following graphs represents his profit as a fraction of the number of glasses of lemonade he sells? I literally think this was in my Econ 101 textbook, so welcome to college, guys. This is actually a tougher question than I think it looks like upon initial read. It took me a little bit to figure out what it meant. So what I'm going to do is it tells us here that profit is found by subtracting his expenses from his income. So I'm going to find his expenses and his income. So his expenses expenses is what he paid up front, right? So he paid $5 for his supplies. So his expenses in this case are $5. Lucky guy that the expenses are just one flat fee. Income is going to be 0.5 times X, which is our glasses of lemonade. So he charges 50 cents per glasses of lemonade. So this is where my initial reaction, because I was like, oh, profit is subtracting his expenses from his income. I read that as you should think of your expenses first, but it's subtracting his expenses from his income. So that means it's really income minus expenses. So that is how you calculate profit. That's a little misleading, but we'll go with it that way. So we're working with the idea income minus expenses. So over here on our y-axis, that's where our income would equal 0, right? Because we're selling 0 glasses of lemonade, our income would be 0. So we want our y-intercept to be -5. Because if we're selling 0 glasses of lemonade, which would put us on our y-axis, so again, 0 glasses of lemonade, we would be making no income and we would have just paid $5 for nothing. So think about this like your fundraising. When you guys buy chips or whatever you buy for your fundraisers up front, you sink that money in and you need to make at least that much back for your club. Otherwise, you just spent $5 for no income, right? So we want to start with our y-intercept at -5. So I'm looking at these graphs. It's kind of hard to tell. This one, it looks like the y-intercept is at 0, so we know it's not that one. Once again, it's not J. I don't really know where that y-intercept is, but it does not look like it's at -5. Same thing with G, actually. So I'm going to cross that out, too. That leaves us with K. See how the y-intercept starts at -5? That's pretty good. I'm going to explain it a little bit further, though. Feel free to tune out of the video if you are totally okay with the idea that you can eliminate all the other choices and it just leaves us with K. But I'm going to talk through, mostly because I love econ, so how we can find the break-even point, too. So we want to find where profit equals 0, which would be our x-axis, right? X equals 0 would be our x at our x-axis, so our x-intercept. Here we would want to set 5 equal to 0.5x, and if we solve that, we'll find the point where when we subtract the expenses from the income, that would equal 0. So 5 equals 0.5x, 5 divided by 0.5, which is the same thing as 5 divided by 1/2, which is the same thing as 5 times 2. So x equals 5 times 2, which equals 10. And here we can see that our line for profit crosses the x-axis, meaning that our x-intercept of this function is going to be 10, which is what we calculated here. This actually took me a couple tries to figure out how to do, so I could probably have explained it better. Again, talk to me. I love talking about economics in case you haven't figured that out by now, so I'd be more than happy to launch into how this would change if we had variable incomes too. Super exciting. So let's move on to this next one though. So what are the quadrants of the standard xy coordinate plane below that contains points on the graph of the equation 4x minus 2y equals 8? I know that's kind of hard to see. So we have 4x minus 2y equals 8. I don't know about you, I cannot graph from standard form because that confuses me. So I'm going to turn this into